Pete Meier, Motor Age Magazine, welcoming you to the Car Clinic in Mahopac, New York, home of TST. We're here to do tonight's first webcast of 2012. Joining me, of course, is someone that you probably already know, Mr. Jerry Truglia. G, good evening.
Good evening, Pete. Good evening, everyone. Thanks for coming by.
I do want to say before we start that last year I came to G and the folks at TST for one reason, to try to provide information and resources for all you guys and gals so life in the base can be a little bit easier, help you fix cars with a little money in your pocket and some food on the table. And we're very proud that last year went so well that we're continuing that this year. Right now we have this one and 4 more scheduled. And so many things going on at Motor Age, I can't begin to cover them all here. So we're going to make it real easy. If you want to keep up with everything we have to offer, just sign up for our newsletter, motorage.com/4text. It's 4 F-O-R text. And that way you'll be the first to know of the next webcast that comes up, our after hours broadcasts, some other things that are going on this year that we'll share a little bit later on. But by all means, check that out, sign up for that newsletter, and stay up in touch.
I think you're becoming like me now. You're adding S. It's for text. It's for tech. T-E-C-H.
No.
Right? I see it up there.
And that's a typo.
Must be a typo.
Oh,
I'm sorry.
okay.
Text. I'm sorry. Put
Hey.
an S on the end. Put an S on the end.
He's in New York, so you got to add S's.
Must be something there in a switch.
Okay. So,
4 text. All right?
so now that we have that straight, we can get on with
And
the show.
that's live webcast. What can we tell you? Tonight's topic, everything you never knew about tapered bearings. We've got a lot of stuff to show you tonight.
Yeah,
a
we
lot
do.
of things I didn't know.
Yeah, learn something new every day, Pete. You know? We have our old nasty habits that we'll tell you about. We'll be honest.
Oh, yeah.
Stuff that we did.
Yeah.
Stuff that, we always did for years, but hey, these guys from Timken's, they know bearings way better than you or I, so we're going to get some real good tips as we go through this.
Typo there, Timken.
Timken.
Yeah.
My New York isn't.
And of course, that's tonight's sponsor. Thanks to the folks at Timken for sponsoring tonight's event, sharing the information with us, correcting us for the error of our ways
That's right.
that we intend to share with you tonight. Just before we start off, let's about a little history of the tapered roller bearing. I didn't know that Timken actually invented the tapered roller bearing.
Nor did I.
And that's kind of neat. I mean, back in the days of the horse-drawn wagons, delivery wagons.
A little before my time, Pete.
Yeah, me too. But down I guess Henry Timken figured out that the wood axles and the wood hubs with some animal fat just wasn't going to cut it, with the loads they were pulling, and patented the first tapered roller bearing.
Thank God he did, because America has to roll, right?
Yeah.
Many cars
now they're
and
rolling.
vehicles have taper bearings besides other bearings on them, right?
Absolutely, absolutely.
Keep it going. Keep it rolling, as they say.
Good. What we're going to cover tonight, first we're going to talk about the construction components that make up the tapered bearing, proper service procedures. Again, this is where I think we'll all learn quite a bit. I never realized, G, that the tapered bearings are actually a precision component, just like any other bearing on the car. I mean, we know how sensitive the plain bearings, main, crank, cam, these bearings are. The tapered bearings are really no different.
No doubt, no doubt. And buying a quality part, such as Timken's, makes a big difference. People buy white box stuff, and they think it's the same thing.
Right.
Totally different setup.
Right, for them to be able to carry the loads that we ask them to carry and then some, because we all know that people abuse their vehicles and try to overload their vehicles, their trucks, especially towing, and other uses that the heavy duty guys deal with, the big trucks, the garbage trucks, dump trucks.
I say a good example is a plumber. A plumber's van, you ever notice how loaded it is? They got more stuff in there to get the kitchen sink in there too. They are a plumber after all. But the weight is unbelievable. And think about what the bearings have to hold, the load that's on.
Right.
So you're going to trust it to an inferior part, something made overseas or something here made in the U.S. with high quality standards.
Yeah, and we're talking about tolerances literally in the millions of an inch in the construction of these products.
Amazing. Absolutely amazing.
We're also going to take a look at some common causes of premature failure. We've got some great examples to share with you here, something that when you're doing a job and you're inspecting the bearings for damage to find out not only are they bad, but what caused them to go bad in the first place. Make sure you correct that condition so it doesn't happen again.
No doubt. The root cause of the problem, very, very important. By the way, I do want to remind everyone out there, if you have any questions please feel free to type them in, and we have Craig and Alex behind there that will say, hey, someone wants to know about XYZ.
Yeah.
If we don't know, by the end of the webcast, we'll get back to you and make sure you do know.
Yeah, in fact, we've got Timken engineers that are standing by, that are watching this right now to make sure we don't mess up too bad.
That's right. They're laughing at us, sir. But
And if we have any questions that we can't handle, well, we'll do like they do on Who Wants to Be a Millionaire. We'll
That's right.
phone a friend. We'll get the answer for you.
maybe Craig will give me $1 million, I'll retire. You won't see my face out here anymore. Yeah.
Real quick, this is an overview of what makes up a tapered bearing. And one of the things I think, for me, makes it kind of unique. If you'll notice, there's a wedge effect between the inner and outer bearings, and that's adjustable by that adjustment nut. So, for example, let's convey it back to what we said earlier, the plain bearings on the engine. You know, if you're going to check the clearance on the plain bearing, you have a specification for that clearance, and then you're going to check it with a plastic gauge, or you're going to measure the inside-outside diameters and do the math. Well, we can't really do that with the tapered bearing once it's installed, but we'll show you a little bit later on how you can get a very precise measurement related to that clearance, know you have it set just right.
Exactly. And that goes, you know, when we look at this, the way that's set up there, making sure the spindle, before we put these bearings on, is in good shape.
Absolutely. No different than looking at the crank journals, right?
Exactly.
Same thing.
Exactly.
Same
setup.
Here are the components that make up the tapered bearing. The outer ring, what I always grew up calling the race, is referred to as the cup. And I think we got one of this. Here's the cup.
Have a cup of tea, will you?
A cup.
That's the cup.
Okay, that's the cup.
That's the thing that's hard to get out that you'll see. We'll do one here live. We already did the other side. But that is something, when you change a bearing, you need to change the cup.
Oh yeah.
Because we know, you know, years back, working in a big facility, there are people that I worked with that when it came to change a bearing, they just threw the bearing in. They didn't bother with the cup.
Okay, and let's be honest. I mean, that's the whole reason that we do these things live and in a shop, because G and I both still do get greasy, and we know what it takes to fix a car, and we also know what happens in the shop. Not saying you guys are doing it, but I bet you every single one of the audience has seen this done. You're doing a brake job, you pull the bearing out, you set it up on the lift, you do your brake job, you come right back, you throw the same bearing back in, same grease, didn't even look at the components, because you want to get that job done and you want to get it out.
Right.
But what happens when you come back a couple of weeks later? Now you got a roaring in the front end, you got some travel issues, maybe some handling issues because the
Or
bearings
God
fail.
forbid, the wheel comes off, someone gets hurt.
In a severe case, yeah,
Severe
if
case.
it's not done
So,
right.
do it right. Keep everything clean when you take it off. A good shop rag, the clean shop rag to put down when you take these things off.
Yeah.
You know, wash them up in a safety clean or suitable cleaning type of machine,
Mhm.
and make sure you visually inspect them very, very carefully.
Yeah.
I mean, that's key to making sure that you're not going to have a failure down the road.
Now the next part, we probably all know, is the bearing. That's what we always call this, but there's actually a combination of parts. We have the bearing assembly, and it's made up of
I know you're a little. I'm playing this Vanna White.
the cone, okay, and then there's the rollers. So we can pull that.
These are nice bigger rollers.
These are the rollers, and you've all seen these. I want to point out here too, an interesting fact. When you look at these, especially on a smaller bearing, you think these are cylindrical, but they're not. They're actually cone shaped.
Cone shape.
There's a taper to these rollers.
And boy, look at this one. Look at the damage. When you can see the damage
Oh,
on
yeah.
that, Craig, I don't know if you can get in on it. No? If I come closer?
I can see it.
Yeah. Well, when we get to, and we're going to cover out exactly what happened to this port, maybe here near the end of the broadcast. And then you have the cage. Now this is a plastic or polymer cage, as opposed to
No.
a metal or steel cage, as you see on this bearing. And the only purpose that the cage has is to hold the rollers in place during assembly and disassembly. That's all it's there for. And one of the questions that I asked when I spoke to the Timken guys was, well, so what's does the plastic mean that the bearing's
Cheaper or
cheaper?
inferior?
If you saw that versus, hey, this has got steel, has high quality part there. And actually, it really,
Maybe in a foreign country.
if anything, the polymer is a better bearing, and the reason it could be a better bearing is that we don't have to worry about this coming into contact with the cup that we showed earlier, because it's not going to hurt it. And because it doesn't have to worry about that, they can place the polymer cage further out towards the cup, and that opens up some space, maybe for an extra roller. And since that's what's carrying the load, it's possible to have a stronger bearing using a polymer cage than one with the steel cage. And again, not always. It doesn't always mean that it's a stronger bearing, but that's one of the reasons, for the polymer cage.
And Timken makes both ways, if I'm not mistaken,
Yes.
correct? Yes. Over the years, when I've used their bearings, I've seen both ways. And originally, I thought the same thing. When I saw that polymer type thing, I said, oh, this thing can't be as strong, but it's actually better.
Yeah, absolutely.
Pretty neat. Moving right along.
Now, this is what somebody said earlier about just normal practices that we've all seen, maybe even done, because we didn't know any better. And that's replacing a bearing, but just replacing the bearing assembly and not replacing the race or the cup at the same time.
So what we're talking about is, this is in the hub assembly. You take it out. This is hard to get out, isn't it? Okay, and we're going to show you. So a lot of people just go, you know what? We don't need that. We're just going to throw the bearing in, and guess what? It's not going to be matched up to that.
Yeah, absolutely.
You're going to run into an issue. Okay, so don't do that.
Yeah, the angles that are used, first of all, let me just explain the first part. If you look at the orange shading on the picture, that would be the existing wear pattern on the old cup. And now we say we're going to leave the old cup in, we're going to put just a new bearing assembly in. The new bearing is actually going to ride further out in that aqua blue area. And that actually causes more heat and less ability to handle the load,
No doubt.
because we're not getting the design contact that we're supposed to get. These angles between the cup, the taper of the bearing, and the taper of the cone are all factored, again, with a millionths of an inch, and not every manufacturer uses the same dimensions. That's what you can see right here in the next slide.
Correct. So, meaning brand A may be a little different than Timken or brand B, right?
Sure, absolutely.
So you need to make sure that you put them in sets.
Put them in a match set.
Match set, very important.
We have a couple questions.
Sure.
See if we can answer.
Please restate the question.
Sure.
As far as the polymer cage goes, does it have better heat transfer? Does it make the rollers ride smoother? I know you said it doesn't hurt the cup, but I'm assuming it's weaker than steel. How do the service intervals compare?
Okay, for the bearing itself, doesn't care.
We got to repeat the question.
Yeah, oh, I'm sorry. The question is there a difference in the service life or the heat transfer of a polymer cage versus a steel cage? And the answer to that very easily is no. There's no difference between what type of cage is used in terms of its service life or maintenance intervals, anything like that. The only purpose for the cage is to hold the rollers in place when the bearing is not installed. Okay, so they don't go falling on the floor.
That's all it is.
That's all it's there for.
Remember, the load is really carried right on here.
However, when we get to the inspection section, we are going to show you a few tips about the steel cage that you absolutely need to know about.
And the mistakes we all make, because I'm going to tell you something that I've done for years when we take this rotor off the spindle. And it's a common one that everyone does.
Absolutely.
For years in this business, I've seen tons of people do it, and again, I've done it multiple times.
To be quite honest, I didn't know till tonight that what I was doing was a potential problem. See another question there, Craig?
Is there a way to get specs that prove the difference between inferior and quality parts?
Whoa.
Wow.
Is there a way to get specs between inferior and quality parts? I'm going to take a crack at this. Someone like Timken is an ISO, has an ISO standard where an OE is going to approve this. And the process of the way they make stuff is pretty much by the book. Where you get something that's made somewhere else, it's not going to have that type of quality.
I'm going to give you as a side note to kind of illustrate that too. Just got back from the Mobile AC, or Max convention.
Yep, that was in Las Vegas.
And we've been printing the press releases from both SAE and Neutronics on the rise in counterfeit refrigerants. You can get a can, 30-pound cylinder, looks exactly like the product you buy from your reputable dealer, right down to the Made in USA sticker on the box. And it's got anything but in the can.
Everything from sand, water, R12, R22,
Yeah,
and a 134 bottle.
There's something, I'm just going to interject this real quick. Some of the stuff is coming R40. So far, there's not been the case here in the North American market, but it is being seen overseas. It's gotten into U.S. military vehicles in Afghanistan. We know it's there. So what we're trying to do now is put a big fence up to make sure it doesn't happen here. If you want more information on that, go to motorage.com to the community site, plug in R40 into the search. You'll get the updates on that. This is not the topic for that. Long way to go around to answer the question. You get what you pay for. Bottom line, you get what you pay for. Other tolerances is fine as a quality product that's going to last and not cause any problems for your customer, or it's going to be one that gets by until the next brake job before it fails. What do you want to install for your customer?
When you get the white box thing, the guy coming around with the van selling you something on a deal's not a deal. This is, a vehicle that's a 3,000-pound gun or 4,000-pound gun that you need the proper bearings on or the proper parts. And going with a name brand that's been around for years that has an ISO certification, all of those things are important. Absolutely. And Tim Kin has been in vehicles for years upon years. So,
can I have a comment?
Sure, yes. Craig has a comment.
Comebacks don't lie.
Comebacks don't lie.
You know which parts are coming back on you, and you know which country they're being made in as well.
Okay. Right.
Simple as that.
And if you're a shop owner, you've experienced, just like Craig has, you've experienced that problem. I hope that answers the question.
And unfortunately, people always go by price. Don't just go by price, go by quality. I think that would be a good thing to say.
Is load-wise the cage material irrelevant? I think someone's asking for clarification.
Yes, again, is load-wise, is the cage material, whether it's polymer or metal, is that any indication of load? No, not in and of itself, but in the design capacity that the polymer does allow on some bearings for the addition of an extra roller, and that does increase the capability. But in and of itself, no. Holding the same part in your hand from one guy to the next, one polymer, one steel, does not mean that the polymer is a better bearing than the steel.
Now, maybe one thing we should illustrate now is what people do with the rotor when it's on there. When this is on, we all tend to take the nut, put the nut on here, go in a couple of threads, and when this bearing is in there, because we want to take the seal out of here, right? You want to bang that out, we all tend to do one of these. And it comes out because this kind of catches like this and hits the seal. But what you're doing is potentially damaging the cage and the rollers. So it's not a good idea to do that. And I've done that. I made mistakes, done that for years.
I don't know if you can see this here, Craig, and I'll try to point out here. Notice how the cage on the large end of the bearing is well away from the flange of the cup, or the cone rather. Okay. We turn it around, which is the direction that G would have just had that bearing in. Notice how the cage, I don't know if you can see it, actually protrudes above the surface of that cup. So that nut is hitting the cage when you're pulling it out. And you risk damaging the cage. And we'll show you why that's an issue when we get to the surface.
And I bet you've all done it, just like me and Pete and everyone else. So let's put this back. Any more questions?
Last question for now. Are bearing cups and are bearing cups and cones individually matched to a particular bearing set in a particular box only, or are new parts interchangeable within the same bearing type and manufacturer?
That's a good question.
You have to restate.
The question is, and correct me if I get this wrong, let's say that I've got, and we have them here, right? I have multiple boxes of the same part number from the same manufacturer. Can I interchange pieces in the same box? That's actually a good question. I think maybe we should phone a friend.
Yeah, I think we need a lifeline, as they call it. I would say it's probably better not to, but
And I'm kind of thinking that if it's a quality manufacturer,
It probably is not gonna matter.
then the tolerances are enough to make sure that that's not an issue.
But let's see if we have another question while we're calling the expert in. We're only make-believe experts here, by the way. No, we really do this type of stuff, but, you know, we can't, no one knows everything. I always say I have the G, I have a half an O. If I had the other half an O and D, it'd be
There we
God,
go.
and I wouldn't be here. So we can't do that. Whoa.
He got his fax machine.
Okay.
We'll retry. Do we have another question? Well,
Why
Rick,
don't-
if you're on there watching,
please call us.
please call us out.
So why don't rotors come with wheel bearings? Someone asked.
Rotors come with races, if we're talking this type of setup, but they don't come with bearings that I know of.
And that's an excellent question.
That is
If
a good
that comes
question.
with a race,
I'd pull that
already
race
installed.
out, but I would pull it out if I was buying this Timken bearing. I know this is matched to that, rather than taking a chance of who knows where that rotor was made. By the way, when we've done stuff with another company that cuts rotors or matches them, we've seen a lot of poor quality rotors out there. Very poor quality. So I would tend to say on something like that, change the races that come in the rotor and put the ones that come with the bearing. Any other questions?
When replacing a rotor that has a new race already inside of it, should you also replace the new race to make sure it matches the new wheel bearing you use?
Okay, we just went over that with the replacing the rotor that comes with races. Should you replace the race with the new one? Yes, I would definitely think that'd be way better, because the race from that manufacturer of the rotor is most likely not going to match up with the race from a Timken or any other particular
There
part.
we go. There's my man.
Okay, I think we got the lifeline on.
Hey there, Rick.
Where's Regis when you need him?
Hello. Hello.
How are you?
Good.
Good.
Hey.
The phone didn't work for some reason, so we called you back on the cell phone.
Hey, no problem, Rick. I think when we called you in, we got a fax number.
Yeah. But now we got the real man on who's going to ask that question. Craig, can you restate that question?
Yeah, let's see if you can hear this question for us there, Rick.
Okay.
Are bearing cups and cones individually matched to a particular bearing set in a particular box only, or are new parts interchangeable within the same bearing type and manufacturer?
Did you hear that okay?
Yes, I think I did. He's asking if the cups and cones in a box are matched sets,
Correct.
or if you can mix components from the same manufacturer.
Yeah, for example, I got a set for the Dodge we're working on. I actually have two sets, same part numbers. Can I interchange the parts between those two boxes?
Yes, you can. Okay, so there will be a time when you cannot interchange, but it will be marked on there as a matched set.
Okay.
The set part number is for convenience. Okay, so what we're selling you or providing you is the cup and the cone together, but that does not mean those two pieces have to always be together.
Right, unless it specifies so on the box.
It will absolutely say so, yes.
Okay, and the second question we had is, you know, we buy a replacement rotor, and the rotor has races or cups installed. Should we be driving those out and putting the new ones in that came with the bearings?
My recommendation as a bearing designer and as a mechanic is absolutely.
Ah,
You're
good.
not supplied by us, and so you
That would make
will
sense.
have differences between the tolerances of what some other manufacturer makes and what we make. So I recommend you take the extra time. If you have a new rotor, it's all clean. It doesn't take that long to pop those cups out,
Right.
pop the new cups in.
Rick, I agree with you 100%. You know, of course, you know more about bearings than I do, but I would do that anytime I bought a new rotor and I put in a new bearing. I would drive those out. It's easy to do when it's new. Put the new ones in, and then you got it matched up.
Cool. All right, any more questions before Rick, before we cut him loose for a while?
If you are replacing the rotor and it comes with a new race, but you always use the old bearing, what should we do?
Oh, I think we can probably answer that one. First of all, that's certainly no. A used bearing. Oh, I'm sorry.
Oh, if I got a new rotor and I'm using the old bearing, should I do that?
Yeah, I think we can answer that one.
I would say no. I'd say
Probably
buy a new set. You know, again, the weight of this vehicle is on that bearing. Very important. And bearings are not even that expensive.
No, if you're going to do a complete professional job, do a complete professional job.
And by the way, don't forget to put a new grease seal in there, and of course, you know, pack the bearings up.
Absolutely.
With all new clean grease. Very important to do.
All right.
But that's if the customer's willing to pay for it.
Well, if they're not, you put the old stuff in there, you're looking for failure. I would recommend then write it on the RO that, you know, you have a brand new rotor with a different race that is not matched to this bearing. Bearing failure may occur.
Yeah, but you know what, I would have to kind of point out too, that you want that for the liability as a shop owner. I mean, you know what, there's always people looking for the cheapest route.
No doubt.
And there are businesses that will cater to that. But if you're, in my opinion, if you're a professional about what you're doing, and we know a lot of them
Yep.
that have turned customers away because they will not repair it properly. You know, you don't want to repair it properly, well, we don't do that. You know, that's our reputation. I want to sleep at night knowing that it was done right.
You know, another little trick I would do on people, sometimes you'd look, maybe it costs you $50 or $80, whatever the case may be. I'd say, you know, I'm just putting them in. If you're not going to pay for it, I'll eat it. And a lot of the customers, they will feel guilty and pay you for the part. Because you don't want them to get hurt. It's a safety. Here, you know, you're dealing with something, again, on a safety issue.
Right.
And I think you're better off doing the job right. I know you do come across, I ran shops for years, so I can tell you, yes, you do come across some people that want to keep it on the cheap.
Well, Rick, I'm going to cut you loose for a little bit in case we need you again there, okay? So we'll stand you by, and I'm going to keep this number on log.
Thanks, Rick.
All right, thanks.
How about we wait like 10, 15 minutes for more questions so we could get through some of the presentation?
Sure.
Thank you, Greg. And thank you, everyone.
All right, those are great questions. We appreciate the questions. Okay, next up on the agenda, now we're going to talk about actually doing the work. And one of the things that we point right off from the beginning is that, like any other bearing, you're not going to build an engine in a slop house. You're not going to allow the bearings to get contaminated with used grease, dirt, you know, metal chips, whatever. You're going to make sure you treat it in a clean manner. This is no different. Make sure you keep all contaminants away from the bearing so they don't get anything on them. In fact, Tipton recommends that until you are ready to install the bearing, you leave them in the box.
Sealed up in the packing that they come in.
Because they come sealed, they have a protective film on them to help prevent corrosion or damage while they're sitting on the shelf. And that protective coating is actually like a magnet. If you take it out of the wrapper and just let it sit on the bench while you go to lunch, it's going to attract the dirt and debris, and it's going to come out contaminated before you even get started. So until you're ready to use it, leave it in the box, leave it wrapped up.
And if you're using an existing bearing, you want to wash this bearing up good from both sides and make sure you get your cleaning solvent through it. So both sides, get all the old grease out, careful rolling around, and then blow air through this way. Do not spin the bearing. Don't do one of these.
Oh, well, that makes such a cool sound, G.
Yeah,
Everyone loves
it's
that.
true.
Save an old wheel bearing, so when you want to hear the noise, you take the old one out, you blow a little air, and you get a big whoop-de-doo out of it.
Yeah, but you know what? In all seriousness, guys, there's really two reasons that you don't want to use compressed air to spin the bearing. Again, it's a dry bearing. It's going to damage the bearing, so that's not a good thing. But even more than that, and we don't want to see accidents happen. We don't see people get hurt. What if that cage lid's loose and a roller gets loose? While you've got 100 pounds of air pressure behind it.
Yeah.
I mean, we already know, I've got guys I know who got seriously handicapped just from 30 pounds of air.
Right.
100 pounds of pressure is nothing to screw with. That's like a bullet. So.
And that brings up another good point. Taking cleaning solvent and going like this and blowing it into the palm of your hand, not a good idea. That's like an immunization shot with air pressure behind it. The thing to do would be like this, not facing it towards the guy you work with that you don't like, okay? But facing it away where this stuff could come out, not hitting anyone or anything. Very important.
And
the eyes, eye protection.
Eye protection.
Very important. Get only 2 eyeballs and stuff like that.
Now let's get into some service tips. We've already taken the liberty of doing the one side of this particular customer's car, truck, pickup. And we've got the other side down and prepped just to save some time. We only have an hour together, so we want to make the best use of that time. But some points we want to make for you when you're installing the cups into the hub. don't use anything harder than the bearing itself. If you do, it's very possible for you to damage the cup, compress that metal, and actually deform the bearing race, and that's going to show up later in damage.
Scratch it up, cause an issue where the roller's gonna have a problem.
Right. And really came out of brass. I mean, brass is soft. And I wouldn't have thought about this, but the Timken guys tell me that, you know, brass is soft, but it can flake.
It does flake.
And those flakes can get into the bearing, and that's debris. You wouldn't let those flakes into the crank bearings, so you don't want it in your taper bearing. So you want to use a mild steel bar to install the bearings, preferably that fit properly. And we're going to show you that here momentarily. And the other thing you want to do is that, and this has all happened, you know, you got the nut off, you're whittling the rotor or the drum, and the bearing pops out, falls to the floor. Well,
That happens a lot,
if
doesn't
it's
it?
got a steel cage on it, that could be a problem. I mean,
There's one right back there, Pete.
yeah, the one that's.
Oh, the vent one? I don't know where the vent one went. Maybe it's inside. But you could easily bend this one. Because when something bends up, you know, don't think you're gonna take a pair of pliers and kind of bend it back and it's gonna be okay. You don't know the damage that
Yeah,
may
here we go.
occur.
This is applicable on the steel cage bearings. And again, it's all happened to us. You pull the nut off, you wiggle the wheel, it gets away from you, it falls to the floor. You may or may not be able to visually see that the cage is bent. Now, if the cage gets bent, that's going to pinch the rollers. And that's going to restrict their movement. That adds heat, that increases friction. It's not a good thing.
Not at all.
So if you want to check it, this is a really good tip from my buddy Rick over at Timken.
Yep.
Take the cup and install the bearing in the cup. And then you have a reference at the race. Not if you can see that, but you'll see this point here. See if I can hold it up I'm going to hold it up at 12 o'clock. And you can see on the bearing at 12 o'clock, see the space between the cage and the outer edge of the cup compared to 6 o'clock? Can you see that? Okay, this cage has been damaged. And if the cage is damaged, this bearing is no good. It goes in the junk and you go get a new one.
Right.
You never use one with a damaged cage.
Well, not a good thing to do.
Right. Next on the list.
Let me click over to your side.
Okay, we covered the cage damage. Now we're going to go into the proper installation. Again, the whole idea is to use a tool that's going to get on the cup, like G's got here, that's going to get on the outer edge of the cup and not contact the surfaces of the bearing or the cup during installation. Okay, and we've got one here set up. G, you going to show us how that's done?
We're going to do this, and in all honesty, we basically had these out before. I've already cleaned the grease out of the hub. The erasers are in there so you can see. And no, they don't come out easy. You're going to see I have to bang. But we did have them out, so it's a lot easier. When you take the punch to take them out, we're hitting against this part right here. We're grabbing this lip. So whether you use a long punch, chisel to get them out, it's not a problem. If this is ever spinning inside here, which was very common years back, okay, this hub assembly is no good. People would say stake it, right? You've heard of that stake it? Stake it means you would put marks in here trying to hold it. Well, when you have heat and load, that's not a good thing to do. Now, I know it is hard sometimes to speak to a customer and tell them, oh, you know, replace it, but it is honestly the best thing to do. So now I'm going to take the other side out before we put the bearings in, or the races in, I should say. And of course, this one's a little more of a bear. Almost. Okay, so now we have bolted them out. To put it in, first thing you need to do is make sure you clean everything up. Make sure there's no old grease inside here. Your spindle should be all cleaned up, right?
Yep.
A lot of times what I would do, if this is an existing rotor, it's not a new rotor, I would take this and clean it in the solvent machine to make sure there's nothing in here. Dry it up real good, blow it out, whatever you got to do. Make sure there's no residue. The next step is, where's my new bearings?
You know, as a side note there, I mean, typically this is not, you may do this job on its own, but typically this can be part of like a front brake work.
Oh,
You
yeah.
know, and you're gonna have the rotor off and machined, and of course it needs to be cleaned anyway.
Yeah.
So you might as well do the job right and get it all clean.
I'll do the big bearing first.
We'll get the big bearing out for you.
And again, do not remove the bearing from the package. Keep everything around on a clean surface. And maybe, Alex, can we get a couple of clean rags? Okay? So we have the new one here. We make sure it fits our tool appropriately. The tool fits in, not a problem. We start this in here. We put the race in. You hear that noise? When you hear it's all the way down, there's a feeler gauge for 2000s to make sure it's all the way down. But when you hear that, you hear the solid sound, you're usually in. But a good way to check is to
Yeah.
put a feeler gauge in there.
Yeah, this is a good point too, guys, because one thing we want to make sure is everything stays square. And if you didn't get it clean, if you didn't bother cleaning it, there's grease and other contaminants on the lip where this new cone's going to go down.
And you may be cocked rather than being
Right.
all the way down. This is cocked out a little bit. You're definitely going to have a bearing failure.
So if you're looking at the bearing you just took out, perhaps maybe you saw there was an issue with the misalignment, and we'll show you how to tell that in a moment. Here's a way you can check. Take a 2000s feeler gauge and come inside the hub and see if you could get that feeler gauge to go anywhere between the new cup and the shoulder on the
Are you
hub.
good with that, Trey? Okay.
If you can get that feeler gauge in,
You're not
you're
all the
not
way
square.
home.
You're not square. And if you got that good solid sound that you just got, and you got this in somewhere, you need to take it back out and see what's holding it up.
You bet.
That's wrong.
Very important. Let's put the upper one on. Do a little change here of tools.
What
Now,
ab-
another thing that you can do to install this rather than the hammer and drift method, you can also put this in a press. And you use your press to install the race. That's going to give you a lot more equal distribution,
No doubt.
of the pressure.
Way better than my sloppy hammer banging. And so if there's any questions, you guys can get ready to start asking them.
what about
Yeah. They hear that solid, hollow sound? Watch when it's all the way in. When you see a hammer bounces back, that baby's home. In fact, this thing gets a little tight, but don't worry. One shot from the back, don't hit the race.
several shots? There we go.
And now we're all the way in. And what I always recommend is, again, clean rag. Alex, throw me a clean rag. Good man, you can come into the shot, don't worry. No one out there is gonna bite you. We clean it up good, and we're gonna get ready to pack the bearings in a little bit. We clean it up, you make sure you have absolutely no dirt like this around, the rust from your rotor, or brake drum, or any assembly. You don't want that around. You clean it, put a clean rag down, and then you're ready to put some grease in here. And we'll talk about that.
We'll go that here in a second.
Okay. Take it away, Pete.
Did you see you had some, any questions there, Craig? Or?
Yeah, what about the aluminum bearing / race drivers that all tool trucks sell?
Okay, now we actually saw those, and we looked. One of the techs here actually has that type of installer, and if you look at it, it is tapered, but that taper is nowhere near the actual surface of the cup. As long as it's not in contact with the roller surface on the cup, it's fine.
Right.
The pressure needs to be applied on that narrow shoulder on the cup.
Any other questions?
Will the mounting cones from brake. I can't
A
even.
brake lathe?
Brake lathe?
Yeah.
Mounting cones from a brake lathe. Oh, I know what you're talking about. The old brake lathe, when you have the cones that go in, if you're not doing them on the vehicle,
Right.
will it affect the races in there?
Now, are you asking that, or are you asking if he can use that to mount the race? If
Oh,
you're
yeah,
asking,
what's
if
he
you're
asking?
okay, I guess what the question is, it sounds like to me is,
Well,
can you
damaged
use
cup
that?
facing.
Can you use that to install the race?
But I think he's saying it will damage it.
Okay.
Yes, yes.
If you're installing it in the way you're supposed to install those adapters to do the brake job, to turn that rotor, you're fine. You're not really applying any real pressure to that surface. I would make sure that they're clean. I would make sure there's no debris or any damage to those that
Or
can be
any
transferred.
chips, correct.
Any chips, anything like
Because
that.
most of those go in to the bearing and just hold them there.
Right.
It shouldn't be spinning on it. It's just a fit that goes in like this to lock it on and the lathe turns. It shouldn't be spinning where the rotor is spinning on that piece.
Right.
The bearing race going like this on it, that's a problem. But if
Yeah.
they lock it up tight, everything is clean, you're good.
Yeah.
Okay.
Someone says they repack bearings all the time. The old ones, they don't have any problems.
Are they using the same exact grease? If you're packing bearings and you're not cleaning them and you're putting new grease on, that is a way for the bearings to break down. You ever see where the grease gets liquefied in the cup? It's all like thin and breaking down. When you see stuff dripping out, when you take it and it's sloppy and loose, it looks like almost oil coming out rather than grease. Someone has taken old grease, put new grease, or mixed different greases to cause a problem, and that will lead to bearing failure.
Let me ask you this, and we talked about that today. I've rarely had any problems that I'm aware of, okay? But did that customer get the full life out of that bearing that he paid for? Did he get half of that? Did he develop excessive play like this vehicle had when it came in? There was a lot of play that indicated a bad bearing. We'll go over that here as we go into that part of the service. But that wobble can cause problems with the brake system, tire wear, overall handling, and in the severe case, could lead to a catastrophic failure. I know I've seen more than one car sitting on the side of the road with the wheel not attached to the vehicle anymore.
Oh, without a doubt.
Okay, so I would say this to you. If you're not following the proper procedure, that's your business. It's our intent to show you, from what experts in the industry have shared with us, the right way, the best practice, if you will, for a very common service. I know guys who have slapped together engines and tell me they have no issues with them. Of course, if the customer has an issue with it, he's probably not coming back to you to tell you about it. He's probably now at your competitor.
Like some of the old flat raters on some of the cylinder heads, lift the head up, throw the gasket in.
Oh yeah.
That is not the right way to do it. Does it get some cars out the door? Sure it does. But would you want that done to your own car? Would you like a dentist going in and doing a half type of job in your mouth?
Yeah. And to be
It's
quite
pretty
honest,
much the
how
same
long,
thing.
the
It's not
time
professional.
difference is minimal.
It is.
The time difference is minimal.
Doing
I
it
hope that
right.
answers that question.
We're professionals, so let's do it right.
Is using, let's say there's a quality bearing in the car, but repacking it with new grease, that's an acceptable practice in this.
If it's
If
clean.
the bearing is good shape, sure.
Sure. Clean
And-
the hub, clean the spindle, and clean the bearing and repack.
This vehicle was a perfect candidate for that. Perfect candidate. Again, as it came in, and I'll go ahead and stick this in now since the topic is up. But the question is, can you just clean and repack an existing bearing assembly? And the answer is, if there's nothing wrong with the bearing, absolutely.
Why not?
But the question when it comes in and you're doing your preliminary checks and you've got the wheel, 3 and 6 or 3 and 9, and it's got play in it, and 12, and you got play in it, you suspect there's a problem with the wheel bearing, you need to take the time to take that apart, clean it out, inspect the bearing for damage, and then make the necessary corrections. Now in this case, this had a lot of slop in it. I thought for sure these bearings were going to be absolutely junk. But here's what we found out. This is just an example of, yeah, here it is. No, this is the one that we took out of this truck. Now I have, and I don't know how well you can see it with the camera there, Craig, but if you look inside the cup, it's pretty smooth. I mean, there's really no sign of real damage. The shaded area where the rollers were riding is nice and even around the entire circumference.
Pretty dark, but
There was no visible damage to the rollers themselves, I went ahead and separated the cage so I could look at the cone. And the same thing there, no indication of heat, galling, damage, anything like we're going to show you here near the end of the webcast. But you know what caused all the play? Here's something that again, until I started working with this project with you and the guys at Timken, I'd never even thought about. What's between the bearing and the adjustment nut? Does this look familiar? That little notched washer in between?
Look at where.
And if you look on the other, I don't know how we can see this in the camera, but there is a physical groove.
Looks
on
like
the
my old
bearings.
records.
Yeah. Physical groove on the back side of this.
Yeah, right in here.
And that is what ended up causing the excessive end play, the rocking that we got. Now, because now we had an excessive end play condition, that could lead to accelerated bearing wear, premature failure.
Right.
Okay, but we could have just cleaned them up and replaced them on this particular car.
By the way, we tried getting a couple of new washers today. We have to get them from the dealer. So we have to temporarily put it back together with this washer.
Well, let's say this is one of your techs.
Yeah.
You know, he knows he's got some brake work to do. He's kind enough to let us use his truck as a guinea pig tonight.
Yeah.
So he's getting a bearing service out of it, and he's going to take care of the washers and the cones here later.
He's going to fix that up.
All right. Any more questions at this point, Craig?
Someone says you really need to check for CG LB spec on grease to be sure that it works for both chassis lube and bearing lube.
That's a good point. And when we get to lubrication, we're going to tell you exactly that. But yes, it needs to meet the specifications for the application. Absolutely.
Definitely.
So yeah, it was needs to meet the specification of the lube that we're going to talk about.
And we'll get to that point.
And there we go.
There it is.
Lubrication.
Look at that. Very good question. So
According
right there.
to the folks at Timken, half of the bearing failures are related to lubrication. But let me clarify that there's a lot of different things that are related to lubrication.
No doubt.
You can use too much. You can use too little. You can use the wrong type, as was just pointed out by one of the folks in the audience. You can mix match grease. And I didn't know this, but you know that grease is nothing but oil suspended in a wax.
Right.
And that's grease. But not everybody makes it the same way. You can actually have greases that will interact with one another, and then they don't grease worth a darn.
Right.
So you can't mismatch the grease. Not changing it or following the maintenance schedule. You know, if it says in the service information that you need to repack the bearings every 60,000 miles, then you need to repack the bearings every 60,000 miles. You're not going to let your oil change go that long, are you?
Nope.
So it's the same type of thing. There's a maintenance specification for that.
And you know, when your brakes would go on a car, and here's the problem with sometimes things that go on in the industry, people pad slap it, they never take the bearings out and check it.
Yeah.
And it's very, very important to do that.
Yeah.
Again, you know, you're not comparing installers that are out there versus technicians / mechanics trying to do a right job.
Yeah.
Doing the right job means you're not only going to put pads on this, but you're going to machine the rotor. You're going to definitely, you know, mic everything up. You're going to clean and check the bearings and put a new grease seal in there.
Absolutely.
So we don't get the other contaminants like water or dirt or whatever coming in.
Yeah.
So it's important.
And that's an interesting point too there, water contamination. You know, that you can have that issue just for the bearing just sitting out of its package. You clean up the protective coating and it's just sitting there, or you have the used one that you cleaned up for reservice and you let it sit there. You don't get back to it till the next day. You're waiting on a part or whatever. That's enough to start the process of erosion on the bearing. And we'll show you some examples of that.
Or like today, when it was raining here a bit, and a little snow, by the way, amazing. Our first little snow in a while.
Yeah.
If your bearings are underneath here and you're not careful where you put your rotor and your bearings, that water and salt or whatever can get into the bearing and cause contamination.
And a little tip for you guys who have the boat trailers, the utility trailers, RVs, you know, anything that's going to sit, you know, the time to service those bearings is right before you put it in storage, not before you put it back into service.
Right.
Because you want to get that contaminated grease, that any water that might be
And
in
everyone backs those trailers right into the water, don't they?
Yeah, so get that out and then repack it with fresh grease. You'll save money because you won't be buying the bearings. You'll just be
Or spindle.
your service. Or the spindle.
Or lose your boat going down the road when the wheel falls.
Yeah, right.
It's even worse. So the right lubrication is super important.
As pointed out earlier, this is a specification that Timken recommends for their bearings, the NLGI GC-LB certified. And yes, this is sponsored by Timken. But Timken tells us that for their bearings, sure, buy the Timken grease, but as long as it meets the spec, they're good. They're good with that.
Right
Just
on
make
the,
sure it meets
right
the
on the
spec.
can. As long as it meets that specification.
Now, how to lube. How to lube the bearings. We've got some bearings that we're still working on installing, so let's talk about lubing them puppies up.
You got it.
Everybody has one of these in their shop, I bet.
And you noticed I had a rag over this. When you put this away, it should always be covered so debris when you're blowing stuff or dirt blows in or whatever.
Right.
You should also make sure that your cover is clean, not full of dirty grease or debris, and in here, where the bearing is going to go, is clean. And of course, we put in that beautiful grease in there, and the proper grease is in here. So when we put a bearing in, we are actually have a clean surface to start with and no contaminations. Very important.
Where's a real common mistake too? Again, we know this happens in the shop. You didn't clean the bearing, or your buddy didn't clean the bearing, or the guy 2 stalls down from you throws that nasty, dirty grease into the bearing packer and starts mixing with the grease that was already in there, and now you're
Chuck it.
It's contaminated. Okay.
And by the way, you don't have to throw the unit out. Take it apart, clean it up, and you're ready to roll.
Yeah. So for all the reasons we talked about don't mix the grease, don't stick an unclean bearing into your clean grease.
So we'll do this 2 different ways. We will pack the bearing, one in here.
Sure, you can pack a little one.
Yeah, where's my little baby?
There's your little one.
Okay, so here's the little one we're going to put in here. And
I'm going to do mine the old-fashioned way. I'm going to take a big glob of this good old grease.
I think he just likes the feeling of that
I'm
stuff.
going to lay it right in the palm there. And guys, this is a perfectly acceptable method. You take the big end of the bearing and you just force that right down.
You should see it come right through the
You'll see it come
backside.
through the backside. And just keep packing that in there.
And we did this for years because they didn't have
we
this
didn't
store.
have the bearing. No, yeah, somebody got rich inventing the bearing packer, but we're just going to force that right.
He's going to need a glove break after this.
And you know what? If your hands are dirty, this is pretty good stuff for cleaning them out.
Yeah, it does get a lot of the grease out of your hands. Just like motor oil. Sometimes when your hands are real dirty, put some motor oil on them and you get a lot of the grease off.
Also get skin cancer.
And once you know you've got it and you can see it coming through the other side, you know you've got it inside that inner cup, then take another nice little smear all across the outer rollers.
And then you have spare to put some on the spindle, right? And you have spare to put some inside of the hub. So he's doing the spindle up there. And make sure, the reason why you want that is you don't want any moisture going on there. You don't want any rust or anything happening. So he has a nice, clean coating all around here. So it's completely covered. Now it's going to go into the hub.
Now we're going to just take some of the grease from over here in the hub. Now here's where you could get carried away. I said earlier, too much is just as bad as too little. There's a space between the 2 cones that are installed in the hub, right? So we don't want those getting rusty or corroded because that'll flake off and that becomes debris that can get into the bearings and lead to premature failure. So we're just going to put some in there and we're going to coat the surfaces that aren't already going to be coated. And no more than the amount of grease that it would take to fill half the space left over between the inside diameter of the hub and the spindle. So it's not much. You just need a film there to keep it all,
Keep the moisture out and keep everything.
keep it from corroding.
And I'll lift it up for you, so you get this end of it a little bit. And remember, we have a clean rag underneath.
Okay. Now once we got that inside all nice and coated,
So we just show them we got both sides coated. Just make sure the rag is nice and clean here. He's gonna put the
I
bearing
can
down.
drop the bearing in place. She can
And
install the
where's the
seal. Should be in the box.
Timken seal.
And while G's getting that out, here's a note that you probably didn't think much about either. On the dust cap itself. You know, the dust cap is a seal. It needs to keep the debris and the moisture and everything out as well. It should also be cleaned because any rust or corrosion that builds up on the inside can get into the bearing. Again, you don't want that stuff in your plain bearing, your crank, or your main, or your rods, right? So why would you want it in your wheel? So I'm just going to take a little bit more of that grease, and I'm going to put a little bit inside the cup as well. So that's all ready to go. Then I'm going to change out here.
I'm building a house. I'm making sure the seal is down all the way. I'm cleaning off any excess grease.
How does excess grease cause bearing wear?
Excess grease affects how it can dissipate the heat. If you use too much, it will cause it to run hotter, the same as it would if you used too little. One good tip that they gave us at Timken, you know, the seal is designed to bleed off any air pressures, even though it's very minor, or excess grease will come out of the seal. So if you're working on the vehicle and you see grease on the back side, you know, leaking past the seal, it may not be an indication necessarily of a bad seal. It's too much grease in there to begin with.
Okay, now we're going to take, this bearing goes in there like this, the small side down. I usually stick these in a vise. I put it like this in here and do one of these, but since this is a little bearing, I'll use my big fat weight and push the grease right through it.
Now there's like little holes in that base.
And you could see this really coming up right through, a lot less effort than what we have to do manually.
And a lot cleaner.
A lot cleaner. Pete did the hard work. Okay, so I'll just give it one more shot. And now I have all the grease coming through there perfect. We're ready to take this rotor. You know, if there's any grease on the rotor surface, use brake clean, whatever, you clean it down, but he's going to take care of this tomorrow. We have everything all set there. We're going to take this, put it on. We'll get the little bearing. And again, we're only putting this washer on now because we don't have one from the dealer. But Gar will get himself a new washer, or two new washers actually. Re-torque these down like I'm going to show you in a minute. And I'm sure a lot of you go, torque them down? Who needs to do that? Well, there's different ways of doing it. We're going to talk about different ways. In all honesty, I didn't torque them down. I used the method of tightening them up with a channel lock and backing off, putting the cotter pin through, probably most common. But we're going to show you everything so you get the most life out of a set of wheel bearings. And it's not all that hard to do.
Now, I actually want to go ahead and take a look here at a picture we looked at earlier to explain the need for this. Again, these are precision components. They're made to tolerance within a millionth of an inch. And they're using running clearances measured anywhere between 1 and 3 thousandths, I believe is the correct spec for the actual running clearance of the bearings when they're together. If you're putting together an engine and you're checking the clearances on the main or the rod bearings, probably use something like fast gauge to see what that clearance is and adjust accordingly.
Definitely.
Same thing here, but we can't use plastic gauge, so we're going to use how much axial or end play there is in the assembly to tell us if the clearance is right. Now, the reason we're doing that is because the way this bearing is set up, the inner and outer form a wedge, if you will. And as we start applying tension on the nut, we take the play out until we come to the point that they call zero load. So there's no play, there's no movement.
No movement at
but
all.
there's no tension either on the rollers. Now, we were all taught to bring it down, snug the bearing up. That put a preload on the bearing. That helps seat the rollers into their proper position.
Correct.
And then we would back that off to get the final adjustment. But how do you know that final adjustment's right? And again, I asked the question. I mean, I'm doing this for 35 years. Isn't there a feel? Well, maybe you've got a digital torque wrench for a feel, but you know, when we're looking at a few thousandths of an inch, probably not. So we're going to show you a method that's very easy
Right,
to
because
do.
we all did this. We all used this castle nut right here, didn't we? We tighten up the regular nut, and then we would put this on, and then we would back it off a 16th or a couple of these notches here, put the cotter pin through. Well, let's see the right way of doing it with a torque wrench.
Okay, the first step to properly adjust the bearing is to go ahead and get the nuts seated, and then we're going to take a torque wrench and set to 50 foot-pounds. And as we tighten the nut with the torque wrench, we're going to turn the rotor, or the hub. And the reason we're turning at the same time we're tightening is because we want to make sure that gravity is forcing those rollers towards the small end of the cup, cone, and we want to get them up to the other end. So as we're pulling them together, we're creating that wedge effect. We're going to go ahead and turn as we tighten.
That's important to do the turning like that and listening to the click on your torque wrench.
Then once we got to the click, we've got our preload on the bearing. Now we're going to go ahead and loosen that about a turn. And we're going to set the preload now to 10 foot-pounds. Same procedure. We're going to tighten or turn as we tighten. Okay, we got to 10.
And again, you'll feel your click on your torque wrench, or if you don't have that tight, look and see where the needle is if you have a real old style one.
And now we're going to back off just enough, maybe a 1/6 of a turn or more, no more than a quarter, until we can get our cotter pin in. Now in this case, it uses one of those little basket cages for the nut.
And castle tight.
So we're going to get that set up. I'm going to temporarily stick the cotter pin in place so that nut doesn't go anywhere. And I want to point out here that my final adjustment was backing off, not tightening. And I was guilty of this too. You back it off, get it loose. First you load it,
Right.
back it off, and then you would spin it and snug it down until you didn't have any play and it felt smooth, felt good, and you shipped it. Here you're backing off
As your final.
as my final.
Yeah.
Now I'm going to take, I'm going to throw a lug nut on a stud here because I don't want to hammer onto a lug nut, a thread. I don't want to screw up our threads here.
Yeah, it won't be yellow tomorrow, but it's not optional. No,
Then
we'll do it the right way.
Then we're going to take a dial indicator. In this case, it's a conventional brake rotor run-out gauge.
Yeah.
If you have a magnetic base, it's probably a little more convenient. But
Yeah, a little easier.
we're just going to go ahead and clamp that on. And I'm going to set my dial gauge up against the end of the spindle.
Lock that baby up.
See if I can get that on there. Now I know, unfortunately, from the camera angle, you can't see the gauge, but you see the setup. Everybody good with me so far, right? Now I'm going to watch the needle deflection. I'm going to grab the hub or rotor at 3 and 9. I'm going to push in, possibly a little bit. Make sure I've got those rollers where I want them, and then I'm going to pull out the same way. I'm going to watch the meter deflection. I got 0.02 of an inch in this particular case. That's between the 1 and 5,000 spec. I'm done.
Done.
Now I want to point out here that I followed the procedure. I followed up with the dial indicator, but I got a feeling that if I was doing this routinely, after about the 10th or 12th or 15th successive time, I would think I know that I got this down pat. This took what? How long did that take? It took no time whatsoever.
And by the way, I recall recertifying and seeing a picture like that on a ASE brake test question. So doing it right is important, and you do get the hang of it. I know a lot of us use the channel locks, like I said, tighten it up. This is a better way of doing it. And by the way, always take your torque wrenches when you're done, reduce them down to the 0 amount. Don't leave the torque wrenches on.
Only when turned up.
By the way, while Pete was doing this, I cleaned up and put away the grease setup. If you look here, it's all nice and clean and go back, all covered. You should be doing that in your shop as well.
And here's a nice little tip for you. I know if you know the same thing, G, but here's how I was taught to take care of the cotter pin. I have the cotter pin actually facing outwards from the spindle. I'm going to take the long side of the cotter pin and bend it up and over.
Okay, so far, I do the same thing. Let's see what you do with the other one.
And then the short part,
Exactly.
cut it off flush, and I'm done.
That's
Not up
it.
along the side. This is
Exactly.
going to keep that nut right where you put it.
And nice and easy to get out.
Yes,
That,
very
in fact, I showed Alex that a while back. I said, the only way I want to see a cotter.
Yep.
Now, I don't know if it's 100% right, but that's the easiest way. So I'm glad you did it the same way.
And we'll go ahead and polish up by reinstalling the dust cap again. Check the dust cap for damage. You know, sometimes these guys have to drive them out with a punch or chisel. They don't have the right tool.
Holes in them.
Yeah,
they're
if
nasty.
it's not sealing, it's just like a bad seal. You want to replace it with new. In this particular case, they put it on with a hammer and they've got the top all flattened out. So you got to make sure that that's going to seat fully. You know, in
Yeah,
the.
I'm looking
in
for
the-
my rubber mallet, like the hubcap hammer that puts this thing on nice in one shot. And
We'll get that when we're all done. That's all right.
makes it nice and he's going to get it.
Okay. Well, we'll let him look up for
So
that.
we'll move on. Oh, he got a big.
But just to recap on the bearing adjustment. Whoa.
That's a.
Here we
big
go.
thing.
Okay, I'm gonna stand the way.
For grease flies. You can hear when it's home. That's good. We take it, we wipe it up. And you are ready to go as far as the wheel bearings being done.
Cool. So the wheel bearing job is all complete. Just to recap, what we're trying to do is get that 1 to 5 thousandths final end play, the axial plays, check the dial indicator, and here's the steps. Tighten adjusting nut to 50 foot-pounds while you're turning the rotor so that you get those rollers seated on the larger side of the cone. Back it off about a turn, and then go back in to 10 foot-pounds again while you're turning the rotor or the hub. Back that off about a 1/6 to no more than a 1/4 turn, just enough so you can get the castle nut in place, and then check the play with your dial indicator.
Now, you know, Pete, I bet out there's a lot of people, you know, kind of snickering in internet land, you know, out there going, these guys on drugs tightening this up. Look, if we were doing an engine or a tranny,
Yes.
right, you know, something that's that expensive, that big, that you don't want to rip apart again, I bet we'd all do it right, wouldn't we?
Sure.
The same thing here. If this is my car, I'm going to do it right. You know, we learn something new every day. A couple of old dogs here, I'll call him an old dog since I'm an old dog. You know, you learn a couple of new tricks. And
Yeah.
this has been, so far, we're not done yet, a great experience to pick up a couple of new pointers on bearings that, hey, I didn't know this. I'm not ashamed to admit I don't know everything, and I picked up a couple of good points.
And I'm going to
Hopefully you
say
guys
this
did.
too. I'm going to say this too. When you and I were coming up, the tolerances on even the engines would be totally unacceptable on one today.
Exactly.
I mean, what cylinder wall clearance is 10, 12 thousandths, you know, in a 70s engine. Now we're looking at a few
A
thousandths.
few thousands.
Cars today are tighter than they've ever been, need to be inspected more than they ever have. If you're the kind of guy who's going to follow the intricacies on the engine or something you perceive makes a difference, but get sloppy on something that maybe you don't think it all makes a difference. You know, a work habit is a work habit. If you're doing it right and precise on the big thing, you should be doing it right and precise on the little things.
I'd agree.
Yeah.
I'd agree.
How about some bearing failures? Something that you look at when you get that bearing apart. One of the most common is what you see in the picture here: bruising.
There's a laser pointer on there. Yeah, it's there.
Oh.
Yeah, you're hitting up on.
Because they're going to be looking at the big picture there anyway, right? They're not looking at me. But you can see the small indentations. This is not a matter of a problem with the bearing itself. This is debris. This is stuff that got into the grease or into the bearing because something else is failing. So you want to make sure you know what the cause of that was when you're doing the repair.
Wow, look
This
at
is what
this
we
one.
talked about before. This is the water damage that we talked about. Whether it's because that bearing sat exposed, you know, for the day or two, or it's gotten water in your boat trailer, or the water got into the grease. I mean, where else do we use tapered bearings? See, what about the rear end? You know, you're on four-wheel drive, and you got it in the differential, and you got the tapered bearings in there, and you get water in there. and then the vehicle sits for any length of time, it starts to etch. And this only takes hours. It doesn't take days, weeks, or months. It doesn't take long.
No.
And if you run the bearing that got etched in the top left, it turns into the one on the top right, or the bottom right,
Bottom right.
where it actually starts to gall the material. And
You have an example there.
I have an example.
And if, we'll be getting to questions in a second, so.
If you can see the damage here to the bearing there, Craig?
Yep.
That's an example of what happens from water. You can see the etchings right there, the galling in the bearing surface. Okay, we'll go back to this slide. Next example, inadequate lubrication. Let me stress here, just like the Timken guys had to stress to me, we have an example of that one as well, where the bearing overheated from lack of lubrication. But all this means is it didn't have enough lubrication to handle the load. So lack of lubrication in this case could be not enough, could be wrong type, could be thinned or contaminated,
Contaminated.
or too much preload. The initial adjustment was too much, and it was actually pushing the grease out from between the end of the roller and the only place it actually has to slide along the surface, and that's the inside of the cone. Here's a great example of that. This is actually one from overheated to the point where the back of the cone lost its temper and got soft. You can't really see in the camera there, but this is, I've gotten very thin damage here. Here's another example of inadequate lubrication. Now, where else have you seen a pattern like that, G? You ever see that on a plane bearing?
Yep.
For the same reasons.
Same exactly.
Okay.
Wow, look at this one.
This one you say was just a little too tight or overloaded. And remember, we deal mainly in our presentations and in motor aid with passenger cars, light duty
Light
trucks.
duty trucks, correct.
But Timken deals with a lot of heavy duty applications.
Big stuff.
And they tell me, I mean, mining equipment, you name it, I mean, they deal with some big equipment. And they tell me that a lot of municipal vehicles, the garbage trucks, the dump trucks, you know, that they tend to be overloaded and work way harder than they were designed to, and can often result in this. Now here's what we were talking about earlier, the misalignment. That you can see on the photograph how the top left wear is at the upper edge, and on the right side is on the bottom edge, 180 degrees
Because
opposite.
this was like cocked in there, someone didn't get that all the way down in. The line
Well,
was off.
we keep in mind that we're dealing with issues between the spindle and the hub. It could be possible that they're not in alignment because of a mechanical issue with them. It could be because this was installed improperly, or it could be because it had developed excessive play like this vehicle had. And you can check the bearing, and you should be able to move it in and out a little bit. Okay? But you should not be able to rock the wheel. And if you can rock the wheel, then there's too much play there, and that can also result in this type of wear
And
pattern.
you know, here in this state, we do New York State inspections. And a lot of times when you check wheels, you'll come across loose wheels.
Oh, yeah.
Bearings that are bad. I used to do
And
them
in Florida, we don't have inspection laws, and that's why I
Yes.
see cars on the side of the road with the wheel off the
That's
car.
freaking scary.
If you have any questions that we aren't able to cover tonight, or the Timken folks, or we just simply run out of time, Timken has an excellent resource on their website at timken.com/tech series. If you've been to the motorage.com site, it's all over the place, very easy to get to, and a ton of valuable information, there for you.
I'm definitely going to go check that out. I'm seriously interested. I'm not just saying that because I'm doing this webcast with you. But, there's a lot of good stuff on bearings that you don't realize. Okay, and good resources like this, pretty neat. A lot of companies now are starting to do that, but I'm glad they have something like this that we can go to. We should probably take a couple of questions, Craig.
Yeah. If you follow the correct sequence of torquing / backing off a wheel bearing and the end plate is not within specs, what should you do?
Okay, the question is, if we've gone through the procedure that I showed you on adjusting the bearing and your end plate is incorrect, then what should you do? First, go through the process again to see if between that amount of play, between that 1/6, 1/4 turn, can make the difference and bring you back into spec. That may be all you need to do. If you still can't get into spec, you may need to adjust that washer that we showed you. And that's a perfectly acceptable procedure. You may put it on a whetstone and wing it down a little bit, or try another washer.
Or just get a new one.
Yeah, to see if that takes care of the clearance issue. Make sure that the races, the cups are seated the way they're supposed to be, and that should take care of it for you.
Yeah, because you may have missed something. A lot of times, and I've come across this, I've worked with a lot of different people, or people work for me over the years, and they would not drive those races all the way down. And you'll run into an issue. So backtrack would probably be a good thing to do if the washer didn't help. You know, if retightening and torquing it didn't work.
Right.
Next question, Craig. And guys, thank you for asking all these
Yeah,
questions.
it's been great tonight.
Will worn rear roller bearings in a solid rear axle cause drivability issues such as binding in reverse gear, but yet no problem in forward gears?
Bearing,
The question is would a problem with the bearing in the rear axle
right,
cause
only
a
cause
drivability issue, or
only-
binding in one direction and not
only,
the other?
and backing up, you're saying.
Yeah, I would tend to think not.
I think if you had I mean, my opinion would be both ways. I'm not a technical expert on that, but I would think I've rebuilt differentials. I think you would feel that reverse and forward.
Yeah, I think you would feel it
Bearing.
either direction if it was a bearing related issue.
Yeah.
If you were a flat rate tech, how much would you want to get paid for doing the job as good as you have?
Well, take in mind, and okay, the question is, if we were
Flat
working
rate
flat
tech.
rate, and I worked flat rate my entire career.
Well, I've
if
done
you're
it sometimes.
if you're a flat rate tech, and you know, how much would I want to do what we did tonight to do it properly? If I'm doing this, say, example, as part of a brake job, I'm cleaning that rotor anyway.
I
So
always
what
did,
is it going to
honestly.
take for me to clean out a little bit more on the inside and inspect the bearing?
First of all, we were playing the day here. We're a little bit over an hour, I think, okay? But we covered a whole bunch. We were playing the day. If we're taking this off and doing that, what's it gonna take you, 2/10?
Yeah.
It's really not a lot of time.
Yeah,
I think it's
the
minimal,
only thing that's
guys.
really different in the process that I would probably have to incorporate was the check with the dial indicator.
Right.
And if you've got a magnetic stand for yours, how long is that going to take?
Yeah,
You know,
by the
it
way,
really
the-
doesn't take that much.
The other one I have is a little magnetic thing. You pop it on, or you have a little stand that's on the bottom. It's really a lot easier.
Yeah. So even considering the tool that we use, it's not. I don't think it's that
No.
complicated. Go by what the book pays.
Yeah. And usually old data gives you some good time.
And I'll tell you what now. I
You,
mean,
you lose time on a old style wheel bearing like that.
well, let me take
I'll
it like
tell you
this.
that.
I think what is the book time on a typical brake job? 2 hours.
Now, about at 1.2?
All of them are an hour. If you get rotors, depends on the manufacturer, like 0.1 if it's Beamer, 0.3 Toyotas.
To
So
replace or turn.
1.6 rotors and
I had a
pads.
different flat rate book than you did then.
Well, that's all data. That's all data.
Yeah, but so about 1 hour, one something, you can do the job right. You know, if people want a job done correctly, it's a matter of breaking your customers in sometimes. The problem is, again, we have sometimes a lot of places advertising $29.95 or $59.95. It's not the same thing you're getting at a quality shop.
Yeah, and we could probably do a webcast on
Oh,
flat rate.
don't get me going on that.
How about the next question?
Next question.
Webcasts and cheapos.
Well, Craig, next question, please.
Is Molly
Molybdenum disulfide.
an acceptable, desirable EP lubricant for wheel bearings?
I do not think that meets the spec.
Okay.
If it says on the container it meets the spec that we gave you, you're good to go.
Right, I don't
The
think it
question
does.
did come up during the research though about synthetics,
Right.
and that's not an issue. You know, if it meets the spec or better, then
Synthetic,
that's fine.
not a problem. Okay, well, I think we got to finish up a couple more slides and get you guys on your way, and gals.
So again, let me give a special thanks to Timken for all the technical resources
Way to go.
that they shared with us to prepare this webcast. I really want to thank all of you guys and gals for being as involved as you were tonight. Some great questions. Really
Good
appreciate the
questions.
feedback. I'm glad that you find that spending your time with us was
And let's
worthwhile.
not forget the lifeline. what's better than calling a Timken engineer and getting them right on the phone?
Well, that's one of the things that we at the magazine
Excellent.
try to do. We want to make sure that you get the facts, nothing but the facts.
And again, if you have questions, just like Pete said, you can email them to us, and we'll make sure we'll get you the answers.
The one last thing that I want to close with, something very dear to my heart. As I said, I spent 35 years in the field as a tech, and I know what it takes to fix a car, and I know what it takes to make a living in this business and take care of your family. When I got the opportunity to do this with Motor Rage, I looked at this as an opportunity to try to do what I could so that all of you could have the information you need to do the same thing, maybe a little easier. That's one of the reasons I came to find this guy at TST, to help me do what we're doing here tonight for you guys. So I'm very proud to announce that we're taking our relationship with TST one step further. Motor Rage is sponsoring their night big event, March 24th, right up here in Fishkill, New York at the Ramada Inn and Conference Center. Now, I realize a lot of you can't come to Fishkill for the days long event. If you can, we'd love to have you. There's going to be some great training, including a class by Mr. Truglia. Doc Knoll and Jim Warren will be up here doing some ignition waveform analysis tips for you. Some great classes. But if you cannot come, TST just told me that they will make a simulcast available for only $75.
That is
You can
correct.
watch the entire thing, you get the handouts, you get all the material, and you get like 30 days of access to that content so that you can review it at your leisure. So if you can't come to Fishkill, you can...
Let Fishkill come to you.
We can come to you. And with that, again, thanks so much for taking the time to spend with us. We want your comments. We want to know what you want to know about, what you'd like to see for these webcast topics.
Someone wrote flat rate versus doing it right as a webcast topic.
That sounds like a great
That sounds
topic.
like a good one to me. I like that.
Doing it right. But so, hey, from Mayo Pack, thanks Craig for hanging out with us.
Yeah,
Alex
and
hanging out
Alex,
with us.
thank you. And
Gee.
most of all, to you guys out there, keep America rolling. And to my buddy Pete here
Thank you.
and Motor Rage, thank you very much. And Timkins, once again, Timken Bearings, thank you once again.
Have a great night.